So I'm going to talk today about artificial intelligence and machine learning, with the end being sort of talking about some of the changes that Amazon has put in, or that they announced in 2019. I'm going to start from the general premise that at least some people in the audience have investigated machine learning an awful lot, don't know very much about the ecosystem at all, and we'll sort of talk through it from there. There we go. All right. So we're going to start with just a little bit of an overview of what is artificial intelligence. I'm going to say straight up, I am not trying to teach people what artificial intelligence is or how to use it. This is a broad overview. There's a lot of detail in this space, and I don't feel remotely qualified to teach on it, but hopefully this will give you a sense of it. And I'm going to start with talking about what artificial intelligence is not. It is not magic. And it is not mandated a generalized artificial intelligence. You're talking to human beings. So when you hear all of the news stories talking about what artificial intelligence can and can't do, it is neither of these things. And in fact, if you look at what it is, artificial intelligence is really just math. For the most part, it's algebra, with some statistics thrown in there and the occasional calculus. But that's about it. There are terms that get thrown around quite a bit. Artificial intelligence is a sort of all-encompassing space that deals with a lot of different topics and a lot of different methodologies. Machine learning is a discipline within artificial intelligence that talks, usually it's about probability, statistics, and math with respect to data sets that it's churning through. There's several different methodologies that you can use within machine learning to try to address machine learning problems. And then within machine learning, there's a subdiscipline called deep learning, and this is where you start getting into things like neural networks. All of those terms come up a lot, and I've noticed a lot of times in the media they get used interchangeably. So it's worth sort of clarifying what they are. This is an example of machine learning. This is the IRIS data set. It's a data set that gets used for doing regression tests or simple training or those sorts of things on models. It's essentially a relatively small data set used to look at how do you train a model to identify a certain type of virus based on criteria. And the image in the middle of the actual flower is only there to sort of demonstrate what some of the categories are and the features. This is not an image recognition set. This is tabular data. So for every row of the table, there are 4 or 5 features defining, what a particular type of virus is, and along with a label at the end which says, type A, type B, type C. And the entire point of this training model is it goes through and it will cluster up based on the features that you looked at. So if you later get a different set of measurements for an iris that wasn't in your training set, it'll do a prediction based on, in this case, the clustering, to try to predict what kind of virus it is based on those criteria. It's a relatively straightforward example of machine learning. This is another example of it. This is from the MNIST data set. This is a data set that uses neural networks and is a little bit more in depth, where the idea is to train a model to recognize handwritten numbers. So it starts by taking the image to 28 by 28 pixel handwritten representation, and the whole thing out into data, just like we saw with flowers, right? Except every element in the table is one of the pixels. And then it spreads that data out through a neural network. And at the end, the bubbles that you see on the right-hand side of that slide correspond to each of 10 possible digits, 0 through 9. And once you feed the image through the neural network after it's been trained, what you see on the right-hand side, what you see in terms of output, is the probability that the image came through falls into one of the numbers. And usually, it's fairly straightforward to train these models to 95+% accuracy, 95 to 97% accuracy when it does these. It looks really complicated, and with all those lines in the middle, and I said there's a neural network in there, and it sounds sort of like it's magic. That's 2 lines of code, maybe. With modern libraries, the trick is all in the parameters that you feed it, but it isn't, a huge deal to try to code this out. Real intelligence is still needed. When you go through and you do these machine learning models, and you start to practice them, the fact of the matter is that it's still really important to understand both the data that you're putting into it, possible outcomes that you're going to get, but also in general what the model is going to do, because a lot of what is going on at the end of this is you're just correlating data. And we've all heard that correlation is not causation, right? This is one that I happen to pull that shows it. And it's somewhat easy when you're messing around with machine learning and AI to take a set of data and come up with really sort of crap output, even though the math works, right? So no matter how easy it gets, and this will become relevant when we start talking about some of the COVID-19 announcements, no matter how easy it gets to actually go through the mechanics, there's still value in understanding what's going on behind the scenes, understanding the process, the data, and all of those things, right? I'm trying a new thing where I'm using notes and slides that I'm not used to, and my eyes are bad enough that I'm having problems seeing them. So, all right, so make it matter, right? So that's sort of at a high level, here's sort of what it is and sort of how it can work. In both those cases, both the handwriting and the flower data set, right? You start with a set of data, and you have a set of data in which you can say, this is a 6. Right? This is 5. It's supervised learning. You've been able to do some labeling ahead of time, and you use that to do the training so we can do predictions on unknowns. There's full disciplines that talk about unsupervised learning where you don't know ahead of time if you have the right answers. And in some cases, you're looking through broad data sets and you're not even exactly sure what the question is. It's just sort of going through the data and looking for correlations to maybe spark some examinations of questions. And it ranges from there all the way out to you can do adversarial neural networks that feed into each other and back and forth, and they actually have started to develop models where they can get data. So you'll see, and it's still just math. It's still just the same kind of math. It's just a question of sort of how you're chaining it together. They're coming up with models that will produce paintings, will produce music, and those sorts of things. So there's a wide range developing here. Tools to applications. So right now there are a lot of tools in the marketplace, in Amazon and in the other clouds that essentially are sets of primitives that you can use to pull together to build running applications, right? Alexa is a combination of a half a dozen or more different services, many of which are AI based at some level. And there are applications that run all the way through from that, chatbots to Elon Musk's self-driving cars, to schools looking at how do you use artificial intelligence and data mining in your data sets to do student success modeling, right? How can you throw an alert to an advisor based on data related to a student's activities on campus and their sort of digital life that would give the advisor cause to have a conversation and do it proactively enough to catch it before students have problems. It sounds like it can be creepy, it sounds like it can be intrusive. There are also contexts in which it can sound really valuable. And so there's lots of different applications of this kind of tech, even in the higher ed space. I'm going to play a quick video here. This is an example. This wasn't actually from Reinvent. This was from Remars last year, which is the machine learning space and robotics conference that Amazon does over the summer. And this talks about one of the spaces where they applied machine learning and the impact that it had.
Most people look at an Amazon fulfillment center and imagine all the stuff inside. When I look at it, I see data. I'm Russell Algor, Chief Scientist with Amazon Worldwide Operations. And on the order of 10 million items. Computer vision systems analyzing images to help us securely keep track of where everything is. Our fulfillers are largely on a Manhattan style. The paths that the pods can follow is relatively structured and organized. So the first decision I have to make is which orders I want to pick at the same time in order to get the items in the same box. And that's a large combinatorial optimization problem to solve, and I'm solving in real time. Using that information, we try to optimize the pods have to travel that decision and decision application that's running to make those decisions in real time on a constant basis as the information underneath changes. we may build predictions of an action of how likely am I to need to access this pod in the next hour, 2 hours, 3 hours, 4 hours. Once we put a label on the box, the transportation execution systems and processes all have to take learning to build information about how long it takes to travel from point A to point B. To make magic happen and get prime shipping in one day, we need to better use all of that information, which machine learning and optimization at scale enables us to do.
You said magic.
Yeah. So that Remar's conference last year, I had the opportunity to go to. It was a fun conference. There's a YouTube video that I can send around if people are interested later. The tail end of one of the keynotes, they actually put an all-electric drone that they are working on prepping to do drone delivery. And he does a 10-minute presentation on how they're using AI and cameras on the drones to make sure that when they're landing in a backyard, they're doing it safely. They're avoiding things like power lines, which the computers can actually see better than people can looking at the video and those sorts of things. And it's another interesting application of how this technology can be used, regardless of how you feel about drone delivery as a general concept.
Most people look at an Amazon.
There we go. So how does all of this apply here, right? Logistics, as fascinating as it is, and Amazon transformed logistics by applying machine learning and artificial intelligence to how you do package delivery. How does it apply to higher ed? And I believe for a long time that there are, enormous amounts of opportunity in higher ed and here at Notre Dame for artificial intelligence to be applied in a variety of different ways that can transform outcomes, transform safety outcomes, change the way teaching is done. I mean, a couple of the more specific ideas that come out of just this list was, for public safety, AI automatic language translation is pretty good. Originally come from a campus that had a huge international population, and one of the things that we observed is that when people are under stress and they get one of the call boxes, they're going to tend to speak in their native language. Well, wouldn't it be nice to automatically translate that to the dispatcher who probably doesn't speak that language? So even though it won't be perfect, they get a general idea of what's going on. Virtualized instruction, one of the things that comes up in environments, particularly where you're doing a lot of distance learning, where you're doing a lot of online learning, is once you record the content's recorded. If you need to go change the content, it's an effort to go and do re-recording. It's possible now, and the way, and we've seen this all in movies, right? The way movie technology is progressing, we're not too many years away from rendered animation looking like real human beings. And from there, it isn't that big of a stretch of the imagination to imagine a faculty panel putting together course content and automatically generating a virtual instructor that actually delivers the content. And it sort of cuts back from this notion of rockstar instructors causing clogging and queues for setting up classes and those kinds of things. But more importantly, it allows you to just go change a few things in a script related to the content and have it automatically re-render on the fly, so you don't have to spend time, energy, and effort to reshoot an entire video sequence to get that content in place. Now, there's lots of questions surrounding that and whether or not that would be a satisfactory learning experience and whether the faculty would accept it. But the technology is coming along, and there probably sooner than later are going to be contexts where that kind of thing matters. Call centers with our help desk, you can do things like record the audio, automatically transcribe it, do sentiment analysis, instead of relying solely on surveys for customer satisfaction, do automated reports on sentiment analysis based on the customer and the phone calls. Student success and well-being, I already mentioned the idea of watching the digital life of the student and being able to catch changes that could indicate stress, could indicate academic problems, could indicate success. Maybe you want to grab a kid who's doing particularly well and highlight them or something. There's a lot of different applications in higher ed for using this kind of technology. I could probably spend all afternoon just brainstorming ideas. So that's sort of the setup. Now the question becomes, what did they talk about at reInvent 2019? What does Amazon do in this space? So this is a slide that I ripped from one of the presentations at reInvent. And this is sort of the Amazon machine learning stack as it existed at the time of reInvent It's not complete. There are some AI and machine learning things on here like Deep Racer that are reflected, and that might be for good reason, but it's a relatively decent layout of what their space looks like. If you look at that, the dark white outline and any box that has red in it, or the red word new in it, is a change. And it is, they almost double the amount of machine learning options that they had in their stack this year when they were doing this. And almost all of them are driving towards it being easier to use. Now, I'm going to change up the terminology a little bit. I made a distinction earlier about what the difference is between AI and machine learning. Amazon uses that terminology completely differently when they lay these slides out. AI services in this context is, think of it as AI as a service. This is a pre-programmed, pre-trained service that you just go and use. Where a machine learning service is more of the platform layer. So it's machine learning platforms. This is the IDE and the interface in which you would go if you wanted to develop your own thing. And the bottom layer is the frameworks, the hardware, and all of the infrastructure that you need in order to support those things, and if you want to dive into getting that hands-on yourself. So the AI as a service, that top layer, these are the things that they announced or substantially changed this year. Kendra is an interesting application. I thought a little bit about how we could apply it here, but this is essentially managed search. Instead of Google on campus, Google and Microsoft both have competing products in this space. I think that Amazon's honestly trying to catch up here, but the idea is you put agents on campus and you set them on corpuses of data, and you get machine learning, more intelligent, more natural language processing, search on top of that. So you could envision, for example, setting this on top of the knowledge base. So instead of necessarily depending on the ServiceNow search interface, which is more keyword oriented, this becomes more of a natural language sort of thing. Contact lens related to Amazon Connect. Amazon Connect gets into some of the features that I was talking about that allows you to sort of extract and react to some of the activity that's going on without having to manually enter these transcripts, sentiment analysis, logging those. Not clear to me right now how well that would integrate with ServiceNow. I just haven't looked into it that much. I think Connect is clearly a competitor to the Cisco environment we have today, so this probably isn't a drop-in replacement, but it's probably worth keeping an eye on if features and functionality you're developing there that we want to take advantage of. Fraud detectors, point of sale fraud detection, augmented AI is, if I remember correctly, that's a workflow through which if you're trying to train a model or you're executing a model and you've been logging and debugging is showing that anomalies are starting to crop up, it can automatically bring people into the workflow to do validation and sort of allow you to retrain on the fly, uses mechanical code. If you're familiar with that, to sort of feed data to people to validate. Deep Composer, I think Brandon talked a little bit a couple of days ago. This is one of the more creative adversarial network things that allows that, I remember correctly, you push buttons and it creates whole tracks of music in a synthesizer that you can play along with. Deep Racer, is anyone not familiar with Deep Racer? I'm not going to belabor the point of it. So it's RC cars, auto programs. So think Tesla auto driving, except RC cars, and they've got a big competition that they're doing sort of annually right now where the cars run the course. Good computer vision work, it's good machine learning training material. I look at that as sort of a good opportunity to teach people about machine learning more than it has any particular practical application. Code Guru, there was a fair amount of buzz about the moment it was announced that it has some limitations to it, but the idea of this is it's trained machine learning models that will go through and do validation checks on your code. Not profiling, not let's compile and check, but it actually will look at the source code, and based on the source code itself, will throw information at you about where there might be problems in the code. The biggest constraints on it right now are that it's Java only, so it's not going to work well with our Ruby. That I haven't asked for a date for that yet. I'm assuming they're going to branch out to other languages for that over time. And the other thing with Cloud Guru is that it's expensive. very sensitive. Something like 75 cents per 100 lines of code per month. Or something
Charges
like
by
that.
lines of code, which is a strange incentive to put on developers.
Yeah. So there are applications where it may make sense, but whether or not we want to put it in the middle of a CI/CD pipeline in a new environment, like Dave talked about yesterday, it's probably a non-starter with respect to cost as it sits. But again, we're keeping an eye on. And then Transcribe Medical comes up. Transcribe was out 2 years ago, I think. The idea is that you could throw an audio file into it, it'll turn it into text. It was laughably bad when it was announced. I remember sitting in Las Vegas at the event. They announced that I go on with the console, and I throw a file at it, and it was almost gibberish. It was actually worse than Microsoft Skype's transcription at the time, and that was saying something. It's gotten a fair amount better, as we'll see, and they added medical transcribing to that, and I expect this to pick up quite a bit in the clinical sense, but it also, the way they're doing this is Amazon Transcribe has a methodology in it for creating your own dictionary, which can be important in higher ed because as you're teaching topically, you're going to have words that the general public, which is where most of the transcribed training data sets are coming from, you're going to have words that just doesn't know. You've got opportunities to sort of bring that kind of language in and incorporate it as part of the service model. Transcribe Medical is sort of an application of that particular technology. I pulled an example of Transcribe just to see if it had gotten any better. I took that entire first video that I showed, dropped it into Transcribe. Took me 2 or 3 minutes of more time to figure out that I put it in the wrong bucket the first time and it shifted around, the bucket in the wrong region, than it took to actually do the transcription. And this is the output. There are a couple of weird outliers. The Al Gore one, if you caught the guy's name, it was Al Gore, all one word and with 1 L, right? Or maybe it was even 2 L's. Anyway, it was perfectly forgivable that it got it. There's some other things in there where it maybe could have done a little bit better, but honestly, this wasn't that bad at all. And with a lot of transcription, it's labor intensive, and you've got to put eyeballs on everything to check it. And this is technologically, this is getting to a point where it's almost usable as is, and it's getting better every year. Sort of skipping down to that second row in the black slide, this is the machine learning services platform layer. Last year, I think it was last year, 2018, they announced Sagemaker, which was essentially you could go in, you could open a Jupyter notebook, you could do some coding, and then you could, through the AWS console, push buttons at various stages to train a model and then separately execute the model or maybe deploy it. That was essentially what is now called SageMaker Neo. Just that box is what they announced last year, and they had ground truth out for a little bit, which is sort of the more formalized, let's use mechanical if people are training data sets. Everything that's outlined in red was newly announced in November. Studio's full-fledged IDE, autopilot, what is autopilot? Oh, autopilot's the magic thing. I'll talk about that in a minute. Experiment sort of coordinates, and if you're doing it, you're doing a lot of it usually, and so they've built a tool that helps you keep track of what everything you're running is and how it all ties together. They've got a debugger, they've got a profiler, they've got some automated tuning tools that they've put in, and it's all integrated underneath this new IDE. And I haven't had a chance to play with it very much. It's Jupyter hubs, Sage in the same kind of languages. It's a slightly different interface for launching things. And unfortunately, it's all in preview right now, so the pricing is a little bit opaque. I mean, the pricing's there, the pricing pages, you can see that it's there, but it isn't always clear when you push buttons what's actually kicking off under the covers yet. So that'll be worth keeping an eye on. Second video, this is a minute or two of Matt Wood doing a demonstration of the IDE with some of the tools on it.
The aim here is that we want to be able to provide machine learning and put it in the hands of even more developers and data scientists than we've done in the past. I'm going to give you a walkthrough, a guided tour of SageMaker today, using a very simple example. We're going to build a machine learning model which predicts house prices. We're going to do this using a couple of simple parameters, things like the number of bedrooms and the number of bathrooms for each individual house, along with things like the mortgage rate and the price. And we're going to go ahead and collect this. So machine learning learns by examples. And so the more examples you have, the better. We can collect all of this sales information from across the US. Then we simply take it, wrap it up into a CSV file, and drop it into S3. Now we can move into Sagemaker Studio. And in just a few clicks from inside the IDE, we can launch a new autopilot job. We simply just tell Sagemaker where what data is. What Sagemaker Autopilot does at this point is it starts to spin up multiple different models, each with a different set of algorithms, data sets, and parameters. The dirty secret of machine learning is that you don't just train a single model, you train dozens and pick the best one. So here Sagemaker is using all of the information that it has to automatically pick and train the algorithm and the parameters to train multiple different models. And it does this iteratively. We're just showing 4 here, but in the next iteration, it picks the best features using machine learning under the hood in order to seed the next iteration and the next iteration. And over time, Sagemaker Autopilot starts to home in on the best set of algorithms, data features, and parameters to provide the best possible model. And it provides a ranked leaderboard of candidate models, here ranked by accuracy. Now, in almost all cases, you're going to want to choose just the best performing model, so the one with the best accuracy. But because Sagemaker Studio is using the debugger under the hood, it's providing profiling information, and Autopilot is automatically generating the notebooks, you can dive into any one of these individual models and get a closer look. You can look at Sagemaker Autopilot, pull together all that data. You can look at the exact parameters and the exact algorithms that we use to generate it. And because we're using the debugger under the hood by default, you can start to inspect the features and their prioritization inside those models. At this point, when you've selected the model that you want to deploy, you can do that with just a single click inside Sagemaker Studio. It gets deployed, and you can turn on the Sagemaker model monitor. And what we're doing here is we, step by step, start to compare the data which is used to make predictions with the baseline data used to train the model. And at any point, if Sagemaker Model Monitor starts to detect any statistical deviations, it will give you an alert. And that's a really good indicator that you want to be able to go back, look at your model again, and potentially retrain the data. And our aim here.
So, and underneath the platform layer is the infrastructure layer, which is frameworks and infrastructure. TensorFlow, MXNet, PyTorch are frameworks and libraries for doing machine learning. So I said you build a neural network in a couple of lines of code, it's using one of these. And there are a whole set of others. These got highlighted at Remet 19 because they have been integrated with the new Inform instances, which is special purpose hardware, more specifically tuned towards machine learning tasks. And so they have the debuggers and profilers and all of those things that are already built into them. If you want to use one of the other frameworks like Gluon or whatever, you're going to have to do a little bit more work to get it all running. But those will all still just work fine on regular, G4, EC2 instances with GPUs on them and all of that. So that's generally it. Hopefully, it's not nearly as mysterious sounding as it was. If it sounded magical to you, I think it's important to understand that it can be implied in unexpected places, and so it's worth exploring, particularly environments like we have, where we have a lot of data, but we aren't necessarily coordinating it in a way that we can explore it in this way. So I think there's plenty of applications for it and plenty of ways that we can apply it. I think Amazon is doing a good job of focusing on making it easy, or easier to do. But the cautions are, the slide that I showed, correlations, it's very possible if you don't understand what is going on to draw bad conclusions. And there's some downsides to all of the automation. When you look at the Sagemaker automation tool that Wood was talking about on there, my first reaction when I saw the presentation is, well, this is AI that's burning AWS resources in the form of a big Monte Carlo simulation. They're going to run through every permutation. Amazon figured out how to print money again. Right? And essentially it becomes a tool where CIOs are going to get to choose between, do we pay money for staff to hire data scientists to do all of this stuff by hand, or we spend the money on run rate and try to do it automatically and do the best we can to draw conclusions. And of course, that's a spectrum, right? It's not one or the other. It's a dynamic range, and at different points in time or for different applications, you're going to want to look at it in different ways.
And any opportunities you identified there, do you know, are we doing anything with either vendors that we have that are doing our admission stuff or anything that's using any kind of machine learning right now? This isn't going to be like super exciting, but James and I are hoping to possibly use TextRack upcoming project. It's a serious possibility.
Okay. And that's one of the AI as a service layer tools.
It's pretty impressive. You can give it, it's kind of designed for analyzing tax forms. So it's OCR is what it is, but it returns the results to you structured in JSON response. So every table becomes an object. You can actually loop through the results of the OCR process on the table. So if you have image-based data that has tabular data in it, it's pretty powerful. It's not perfect.
You know, another question is, do you know any researchers that are using any of these tools at any level? In some cases, I know Paul Brenner said, yes, researchers that are wanting to do machine learning, and yes, sometimes counsel like, you don't have near enough data to do something that's valuable.
I know Dr. Dan Chen is working on.
And are they choosing things that are at, I'm just gonna do very, something at a very low level versus using something like Sagemaker. Yeah, I know I got all my data on it. I just want to spend more time training models and actually building the tools.
Yeah, sure. We try to introduce them on that particular project Sagemaker. Using their.
Yeah, they're installing like a PyTorch on the bottom end, and then we're like, hey, check out Sagemaker. So you probably can't do what we want. And then I think we finally got it there, looked at it for it. We need to follow that with them on.
I think
there are also examples in public health with mosquito research that WCO working on.
Yeah, I think I don't know if this is global health or not, Cancer Research Institute. I think I saw some news releases of them doing machine learning work. So there are certainly applied AI opportunities on campus, and it's going on. I don't know if there are any researchers who are doing research on the actual mechanics of AI, coming up with new algorithms or whatnot. And then in Paul's case with CRC, right, there's the scale of I want AI to take a look at these manuscript pages with computer vision and sort of straightforward with some tweaks. And then there is large scale machine learning, deep learning at massive scale, doing whether it's or astronomy or those kind of more and more PhD. Right? So there's.
So I'm collecting names for Notre Dame OIT machine learning interest group. Because when the robots take over, you want to be someone who knows how to work the robots. And it's just a fascinating area. So if you have any interest in that, there's no plan currently, but once we get some folks together, I think we can find some good learning resources, figure out some things.
We got this whole robotics initiative, which is pretty much macros on steroids, the way I describe. But that has, probably some potential to become smarter about any old applications that we need to have some robot actually run them.
When we have to start worrying that robots are going to take our jobs.
Depends. If you work in logistics, some of them.
James, actually, James, we all are robots. You're the only human.
This is the matrix. So what seriously related is that the ethics of artificial intelligence, right? We're looking at cancer research and what can be done with large data sets, but take a look at what's happening with deepfakes right now and the use of data algorithmic bias, how that's impacting our world today.
Yeah, and this is one of the cautions about sort of the automated AI model training and those kinds of things is the bias thing becomes even more pernicious because you don't really understand what you're doing. Right. Yeah, at the Remars conference, one of the things that was sort of encouraging that came out of that is there are industry leadership groups that are coming together to try to look at some of the ethical applications of the technology. This is not just Amazon. This is sort of all of the big players who are working in the space, recognizing the fact that there are substantial ethical issues and trying to say, let's put groups together that can start to explore these things and not just be dismissive of it. Because woohoo, we know technology.
this person does not exist.com.
Yeah.
It's shocking.
Oh,
yes.
Or, what's the other one? Which face is real?
Yeah.